everyone, in this video we will talk about some methods that we can use to compare two proportions. So take a look at the difference in proportions between two groups. Now we'll have a different set of methods that we'll actually use to do a hypothesis test, some that are a little bit more general. So in this video I actually just want to focus on confidence intervals for the difference in proportions. We'll start by coming up with an approximate sampling distribution for the difference in proportions, P1 minus P2, and we'll use that approximate sampling distribution to build out our confidence interval. So it turns out that the difference in two sample proportions, P hat 1 minus P hat 2, tends to follow a normal model. When each of the two samples are random samples from a population, so we have random samples that are distinct, that are independent from one another, so there's no reason that they should be overlapping or influencing each other, and when the sample sizes are collectively large enough. And here's what we mean by that. When the number in sample 1, N1 times P1, N2 times P2, N1 times 1 minus P1, N2 times 1 minus P2, if those are all greater than 10, it turns out that this normal approximation is a pretty good fit. Now, we don't have a sort of simple probability distribution for the difference in successes like we would with the binomial distribution. So here we'll rely pretty heavily on the normal distribution or the normal approximation in this class to find a confidence interval. So in order to use that normal approximation, we need a standard error. So here we have a standard error of the difference in proportions. We get the square root of P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 over N2. With this standard error, we'll use our standard or our tried and true methods for finding a confidence interval. So let's take a look at some examples. The way a question is phrased can influence a person's response. So for example, the Pew Research Center conducted a survey with two forms. They asked respondents the following question. As you may know, by 2014, nearly all Americans will be required to have health insurance. People who do not buy insurance will pay a penalty, while people who cannot afford it will receive financial help from the government. Do you approve or disapprove of this policy? Now, half of the respondents actually were given the question as I just said it. The other half had the statements in brackets switched. So the positive statement, then the negative statement. So what we'd like to know is whether or not the way we ask the question affects a person's response. So we have samples of 771 people who had the original question, 732 people who were asked the reverse question. Is there a difference? And here we have approval response rates given in percents. So let's let group 1 be the original statement and let group 2 be the reverse statement. We'll find our standard error first. So our sample proportion in group 1 is 0.47, sample proportion in group 2 is 0.34. Here's our sample sizes for group 1 and group 2 respectively. Plugging everything in, we get a standard error of about 0.025. So to get our confidence interval, we'll take the difference in the sample proportions, P hat 1 minus P hat 2, add and subtract 1.96 times the standard error, and we get a range here that goes from about 8% to about 18%, or 0.08 to 0.18. Now, what does this difference actually represent? Well, it's the difference in the proportion of people who would approve of the policy depending on the wording. So it turns out that the difference in the proportion of all people who would answer yes to these questions based on our sample is between 8.1% and 17.9%. Here we did group 1 minus group 2, original minus reverse. So it turns out that there is a fairly large proportion of people, or a fairly large difference in the proportion of people who would approve of the statement or answer yes, depending on the way in which you word it. So wording definitely makes a difference when it comes to policy approval questions. Let's take a look at another example. The use of screening mammograms for breast cancer has been pretty controversial over the years because the overall overall benefit on breast cancer mortality is uncertain. Mammograms can be rather painful procedures. The idea is the mammogram truly catching the breast cancer in time, or are we finding it too late? So we have data from several large randomized studies that are attempting to estimate the effect of mammogram screening. So we have a 30-year study that was done in Canada on almost 90,000 female participants, so a very large sample. During a 5-year screening period, each woman was randomly assigned to either receive annual mammograms or standard physical exams for breast cancer. During the 25 years following, each woman was screened for breast cancer at his or her healthcare provider. Here's the data. So in the mammogram group, 500 women during that 25-year follow-up period died from breast cancer. In the control group, 505 women died from breast cancer. So there is a slight difference. Is it enough to really conclude that mammograms are effective in identifying breast cancer early? So we'll calculate our sample proportions. So the sample proportion in each group who died from breast cancer, p hat 1 for the mammogram group is 0.01113. In the control group, it's 0.01124. So very similar proportions for our two groups. We probably won't expect to see a difference, but let's calculate the confidence interval to be sure. So finding the standard error first, plugging in our sample proportions and the sample sizes, we get a standard error of 0.0007. This seems like a very small standard error. However, the proportions are small and the sample size is large. So this is a reasonable magnitude for the standard error. Now to complete the confidence interval, we'll take the difference in our sample proportions plus or minus 2 standard errors. We get a confidence interval that goes from negative 0.0015 to positive 0.0013. Now look at what this interval contains. This interval contains 0. So what that means is that 0 is a plausible value for the population proportion, or the population difference, in the proportion of women who will die from breast cancer. So really, there is not evidence from this sample to support a difference. So that gives us a confidence interval that we can use to compare two proportions. In the next video, we will look at some general methods that we can use to do a hypothesis test to compare multiple groups, maybe 2, maybe more. I'll see you then.